Alright, so we're going to review exercise 3.1. A lot of people emailed me, so they had some issues with it. First thing is focus on your givens. What are you given? Well, they tell you that, whoops, hit the highlighter. They tell you that you have a 0.3629 sample, you have 1.0666 of carbon dioxide, and 0.3120 grams of water. So the first step, is you have to find the amount of carbon, grams of carbon using CO2. So what we're going to do is we're going to go over here. We're going to take 1.0666 grams of carbon dioxide. We're going to put it into a grid. We're going to use molar mass as the first thing. 44.01 grams of carbon dioxide using the fluffy bunny is equal to 1 mole of carbon dioxide. Next thing is you need the ratio. If you look at the formula for CO2, how many carbons do you see? You see 1, which means in 1 mole of carbon dioxide, you have 1 mole of carbon. The last step is taking the molar mass of carbon from the periodic table, which is 12.01 grams of carbon. Plug that into your calculations. At the end of it, you should get 0.29108 grams of carbon. Remember, the sig figs are dictated by the given right there. So I have my grams of carbon. So what we just did was step 1, done. Step 2, you're supposed to find the grams of hydrogen using water. Well, if you look, they tell us we have that much water. So our next step is to take 0.3120 grams of water. Molar mass of water, we're going to say is 18.01 grams of water. It's equal to 1 mole of water, which brings us to the ratio inside. If you look at water, right there in the formula, how many H's do you see? I see 2. So in 1 mole of water, I see 2 moles of H's. Last but not least, we add in the molar mass from the periodic table. A mole of hydrogen, we're going to say is 0.01 grams of hydrogen. So then you're going to run that grid, do the calculations. I know you know how to do the calculations. You should come up with 0.03497 grams of hydrogen. Bam. So if you look, we did step 2. Step 3, to find oxygen, we total carbon and hydrogen, and we add them together, and we subtract it from the original sample size. And remember, we mentioned that at the beginning. There's the original sample size right there, 0.3629. So I'm going to go here and say 0.3629 is my original sample size. How much carbon? Well, I'm going to take that, the 0.29108, and I'm going to take that, the 0.03497 grams of hydrogen. I'm going to add them together on my calculator. What you should get is 0.3260 when you add those two together. You subtract them. This is the total sample. You can spell it, total. And this is just the carbon plus the hydrogen, which the leftovers will be just oxygen. That leaves me, when I'm all said and done, 0.0372 grams of oxygen when I'm all said and done. So now I have grams of oxygen, I have grams of carbon, grams of hydrogen. To find the percent composition is fairly easy. You take the sample size, so I'm going to take 0.3629 divided by the amount of oxygen, which is 0.0372 times 100. That'll be my percentage of oxygen, because that's oxygen. Find the percentage of hydrogen, it's the same thing. Take the sample, total sample size is 0.3629. How much hydrogen do I say I have? 0.03497. So I go here, 0.03497. Finally, my carbon, the value I had was 0.29108. So I'm going to go 0.29. So it's 0.29108 divided into 0.3629 times 100. This is how you get the percentages of each of them. So when you do that, you end up with a percentage of each of those. Okay, so then what happens is when you do that, you take the sample of each element, so there's oxygen divided by the total sample, the 0.3629 times 100, you get roughly 10.16% oxygen. Same thing, you take the mass of hydrogen, divide in the total sample times 100, you get 9.64% hydrogen. And last but not least, you take the total amount of carbon we figured out into the total sample times 100, and you get 80.2% carbon. So we've answered part A. We did its mass percent composition. The next step is empirical formula. So basically, you start with all these percents as your empirical formula. Remember, the first step is you change percent to grams. Now in our book, they're going a little crazy as far as the periodic table. They're taking the digits on the periodic table to 3 and 4 decimal places. You don't have to do this in the class, so the numbers are slightly off. It will still work. So if you notice, I've got the 80.2 carbon, the 9.6 we have 9.64, but it's 9.20. And then finally I have the 10.4, and mine is 10.16. So it's close, but there's no need to carry it out 4 or 5 decimal places in the book, like the book does. So the next thing that we're going to do is we're going to change it into moles. How do you change the grams into moles? You divide by the value from the periodic table. So I take 80.23 grams of carbon, I get 6.681 moles of carbon. Take the 9.62 grams, I would divide by 101, 1.01, I get 9.45, and then finally the 10.14, I divide by 16, and I get that. Remember, the first step in an empirical formula after changing percent to grams is to divide by the molar value from the periodic table. So I get the number of moles. My next step is I divide by the smallest number of moles. Well, obviously 0.6355 is my smallest number of moles. So I'm going to divide by 0.6355 into each of these. What I'm going to be left with is, so when I divide by the smallest number of moles, 0.6355, I'm going to end up with this, 10.51. This comes out to be 15.02, and this obviously comes out to be 1. Now, remember the decimal rule. If these aren't really within a tenth of a whole number, that is, and that is, but that is not. That's 10.5. This is where you use decimal magic, because there's no way you can write C 10.5, H 15, O. It just doesn't work that way. So what you do is decimal magic to take out the decimal. When you have a 5, you multiply by 2. All these get multiplied, by 2. This gets multiplied by 2. Your empirical formula then becomes 10 times 2 times 10.5, which is going to be, in the end, is going to be 21, C21. H, 15 times 2 is going to be 30. And then finally, 1 times 2 is going to be oxygen 2. And there's your correct answer. Key part of this one is, remember, when you get to you cannot round after you divide by the smallest number of moles. When you're in this section right here, you divide by the smallest number of moles. The answer choice is right there. If they are not whole numbers, then you have to use decimal magic. And that's how you do problem 3.112.